Very good afternoon. Hello and welcome to the virtual coaching classes for today. And I hope all of you are keeping fine. And today we are taking up the next chapter in our mathematics, business mathematics portion. And that is going to be GP, which is geometric progression. So welcoming all of you once again, let us look into the discussion flow for today. Now, in today's session, first, we shall review some important links for your self-study, including the links for the mock test paper. I received many of your queries, and so I thought that I already explained the process in which you can look into the MTPs and you can practice, but I'll also share the links. Secondly, here we will move into geometric progression. In the last session, we have seen how the AP system works, arithmetic progression. And we are now familiar with the concept of the first term and the nth term and the summation of the terms. So we had analyzed two important formula in case of AP. In GP as well, we shall be reviewing and understanding two simple formula, one for the nth term and one absolutely for the sum. That means the series. As you know, series means the summation of a particular sequence of numbers. Then we will learn about the GM, the concept of geometric mean. It's just parallel to the meaning of arithmetic mean. You know, the concept of arithmetic mean and GM, geometric mean, is quite similar. And the calculation will be just as there's a small difference in the calculation which we will learn. And we shall thereafter devote ourselves to practicing more questions from both AP and GP. I have taken some additional questions which we shall be analyzing and performing, and of course we'll solve those questions. And I request all of you to keep your pen and paper handy so that we can carry on with the discussion. Okay, so friends, we start first with the study links. Now, these are the important guides for your study, self-study, as well as for the practice materials. I am sharing the important link with you. First is the link for the referencer. Now, please note, as I shared on the last day as well, that the Institute has brought out the referencer, which is for the quick revision purposes, and it includes very, very important questions which the Board of Studies has prepared, and it contains questions, solutions from various chapters. Now, so far as the referencer is concerned for our subject, that is business maths, logical reasoning, and statistics, this is the link so that you can download the referencer and study from there. And all the chapters which are covered in the referencer are given in a point-to-point, point-by-point manner so that you can understand, and there will be no problem in following the steps which it has been taken to arrive at the solution. So I request you and I recommend you to go through this referencer. The second is the mock test paper series 1. The Institute has brought up both series 1 as well as series 2 of the mock test paper. So many of you were asking last day, now what should be the approach for the exam? Absolutely, number one, the study materials issued by the Institute. Number two, please go through each and every session of the virtual coaching class. Step number 3, please go through the referencer, solve all the problems. And the fourth step, which I can suggest, is that kindly go through each and every question in the mock test paper, both for series 1 and series 2. This will create a huge confidence in you so far as exam preparation is concerned. Please do remember that mathematics, logical reasoning, and statistics is basically your concept, practice, and time management. And definitely, if you have all these, you develop tremendous amount of confidence to face the exams. So this is the link for mock test paper series 1, which is March 2021. It includes both the questions and the solution. Now, the third link which you see is the mock test paper series 2, April 2021. This also includes both the questions and the answers. This is the link. And also the fourth one is the link to the ICAI CA Students Journal. You can see the archives, all the back issues of the journal, which will give you a lot of important understanding on different chapters, portions of your curriculum, not only for mathematics, but also for economics, accountancy, law, and other such areas. And the current journal issue you can see in the link. So you can take a snapshot of this, so that screenshot of this, so that you can just go through these resources which the ICAI has prepared only for your purpose, only for your use, and I'm sure you will be able to derive a lot of benefits. Friends, we move on now to the understanding of geometric sequence, and thereafter we will move into geometric progression. So since we are now familiar with the concept of arithmetic progression, where we know that, yes, the progression means there is a common difference between each of the terms. And in case of arithmetic progression, we know that we know that when it comes to the arithmetic progression, the common difference, the CD, is same. So if the common difference, say for a progression like 6, 9, 12, 15, so you see it's an increasing arithmetic progression with a common difference of 3. Same concept we have in geometric sequence, and here in place of common difference we use the term common ratio. Okay, so this is basically a ratio of the second term and the first term. So if you look at the screen here, now when we think of AP, we use the term common difference, but in case of GP, the concept is, now common difference, you remember it was the difference between second term and first term. Okay, or it can be in general, it can be term Tn minus term Tn minus 1, right? So that is how you basically compute or you calculate the common difference. But in case of common ratio, as the word ratio means, ratio is nothing but the division of one number by another number. Okay, so therefore in case of GP we will call it CR, common ratio, and it will be given by term Tn divided by term Tn minus 1. So if I have a series like this, say for example 4, 8, 16, 32, 64, and so on. Now, if you look at the series 4, 8, 16, 32, and 64, and going on, well, this is not an arithmetic progression. Why? Because the differences 8 minus 4, 16 minus 8, they do not match. They are not equal. But if I find out the ratio, let's try to compute the ratio. So 8 by 4 gives me 2, 16 by 8 gives me 2, 32 by 16 gives me 2, and 64 by 32 also gives 2. So this is a constant ratio, and therefore these type of sequences or progressions are known as geometric progression, absolutely parallel in nature to arithmetic progression. The same concept, yes, there is an increasing trend or it can be a decreasing trend, but the ratio will be equal. Just as in case of arithmetic progression, the common difference has to be equal. So here, of course, we are looking at multiplication, because 4 into 2 gives 8, 8 into 2 gives 16. Just in the case of AP, you remember it was like an addition, right? So if say for example 2, 5, 8, 11, 14, so this is an AP because we are adding 3 with 2. 2 plus 3 gives 5, 5 and 3 gives you 8, 8 plus 3 gives you 11. But here we are multiplying. So in this particular sequence, 4 multiplied by 2 gives you 8, 8 multiplied by 2 gives you 16, 16 multiplied by 2 gives you 32, and so on. So the concept is quite simple, and since we have already covered AP in details, the understanding of GP will be quite easy. And now we will look at the definition of sequence. So in a geometric sequence, each term we are getting by multiplying the previous term with a constant. Okay, and the constant is nothing but the common ratio, right? Please remember that. And yes, also please remember that 64, for example, is obtained by multiplying the previous 32 by 2. Okay, common ratio is 2. And yes, now let us look at some examples. So 2, 4, 8, 16, 32, 64, 128. You can easily see that here the common ratio is 2, and we are multiplying the numbers with 2. Of course, you may ask, what is the practical significance of learning AP and GP? Well, let me share with you that this will be very useful, especially when you take up in IPCC, of course, when you study financial management, even economics. You have another paper on economics in IPCC. And of course, the concept of GP will be useful, especially when you study compounding in the time value of money. You will find a lot of parallels there. And advanced financial management definitely depends on the understanding of AP and GP series, because in GP we will also learn about infinite GP series, right? So in this example, 2, 4, 8, 16, 32, 64, and 128, we can see that the common ratio is 2, because we are multiplying each of the numbers by 2, and we are getting the next term or the next member in the series. So this is basically the rule. Now let us take, we can write a geometric series like this. So if I just take the common, we will take the general terminology, and let's try to understand how we write GP series. So A is the first term. Okay, now in case of AP, you remember the second term would have been A plus D. The third term would have been A plus 2D, and so on. But in case of GP, we will replace the letter D with the letter R. So D is no longer used. We use the letter R, and R is referred to as the common difference, a common ratio, right? So since it is the common ratio, we will multiply each term by the common ratio. First term is A. I multiply A with R, and I get the second term AR. Then again, AR multiplying with R again, we get AR square. So you've already completed indices, and you know the rules. AR square, once I multiply with R, becomes AR cube, AR to the 4, and so on. So therefore, this is how the common ratio works. And therefore, okay, let me take some questions. Now, what if the common difference is equal to 0? Now, if there's a question from Karan, if the common difference is 0, what happens? This is not a sequence, because it does not change. There's no change, right? So you will find that there is no such concept as having a common difference of 0. Okay, then yes. Yeah, GP is of course a sequence, definitely. And in case of GP, yes, you can see that in case of GP, it is nothing but we are multiplying each of the term by a constant, right? So A is the first term, R is the common ratio, you can see in the slide. And therefore, the rule, from this we can get the rule also of the nth term, okay? Like we saw in the case of arithmetic progression in AP, you may remember that the nth term was given by, let us just write once again, it will be a quick recap, okay? So the nth term in case of AP was A, you may remember what is the nth term? Just imagine, just think, A was the first term plus n minus 1 into D. This was the nth term in AP. But in GP, the nth term, that is term n, is equal to A, which is the common first term. Is the first term, like in AP, it's term 1, here also first term, term 1, into R to the power n minus 1. Okay, where we are trying to find the nth term. So this is the first formula which you need to remember. Just as in case of AP, primarily we had two formula. We had to learn two formula. One was for the nth term, the other was for the summation. Here also there are two formula. The chapter is fairly easy. The first one is the AR to the power n minus 1, which is the expression for the nth term. And here, of course, n minus 1 signifies the nth term, because in case of the first term, when we write, say, for example, the first term we can write basically as AR to the power 0, because you know any number to the power 0 is equal to 1. So R to the power 0 is 1. Therefore, A into 1 is 1 into A into 1 is A. Therefore, You can see r to the power 0 being 1. A into r to the power 0 means basically a multiplied by 1, which is a. Therefore, this term here, the first term a can be written basically as ar to the power 0. And that is the reason why the nth term becomes arn minus 1. Otherwise, it should have been ar to the power n, but it becomes ar to the power n minus 1, which is the first formula which you need to understand. And of course, you need to remember for the sake of your solving your problems. Okay. Yeah, Shomo, there is a question from Shomo Bhattacharya. We can use AP and GP in the calculation of income increasing. Yes. Now, say, for example, in the calculation of an increasing a company's income or net profit is increasing over a period of time. Now, in an AP. So after, if the company experiences the same rate of increase in the profit or in the, say, for example, in the provision for doubtful debt, just, there are different parameters in case of a company. Say, for example, the productivity of its machines is increasing at an AP. So after 1 year, what will be the increase? After 6 years, 10 years, what will be the increase? You can find out through an AP. Same way, this chapter, the understanding of these 4 important formula, 2 for AP and 2 for GP. Right? Basically, we are dealing with 4 simple formula. So this will be useful even for calculations of interest. And in banking sector, before the banks had implemented core banking system, that means software, when everything was in manual form, so these formula were used basically for calculation of interest on loans, interest on deposits, and so on. So these 2 are fundamental chapters of business mathematics. Absolutely. Okay. Okay. There's one question from Pranjali. What is the difference between geometric sequence and geometric progression? Okay. So basically, it's the same. We are in case of progression, and we can write. Basically, we can say geometric progression is a type of geometric sequence, and here the objective is to understand the first term. We also have the common ratio, and therefore we can get the entire progression. That means each term in the progression. Okay. Now, if the common ratio is -1, there's one question from Rishabh. Okay, we will see what is the outcome of having something like that. Okay. Yeah, there's one question from Jay Kumar. Are additional question bank important from the exam perspective? Yes, absolutely important. Please go through the exercise questions and also the additional questions. Okay. Yeah, I explained about that. Common difference is equal to 0. Karan was asking, there's absolutely, it will not be a sequence, of course. Okay. Now, if R is negative, yes, R can be negative, Rishabh. Yeah, see, first you try to understand. There will be a lot of questions which comes in your mind. R can be negative. What happens if R is less than 1? Well, there are different propositions. First, you try to understand the theory, the technique, and then you can find the answers to your questions. Many of these questions you will be able to understand. Okay, so let us take the first example, 1 minus 6. Then we have 36 and minus 216. Okay, so here, if you see whether it's whether this sequence is geometric. Okay. Okay. Now, as I said that in this example, there is something negative. So you can see the first term T1 is 1, and then we have the next term -6, and then you have 36, and then you have minus 216. So we will just try to find out the common ratio. So the common ratio CR is equal to term 2 divided by term 1. So -6 by 1. So I get -6. Also, if I divide third term T3 divided by T2, which is -6, let us see what the answer we get. So term 3 by term 2 gives me 36 by -6, which is also -6. So as per the understanding we get from this, the analysis of this these numbers, yes, it seems that it is a geometric sequence, and there is a common ratio of -6. Okay. The second one is 2468. This is a simple one. Is it a GP? That is the question. Now 4 divided by 2 gives you 2, but 6 divided by 4. 6 divided by 4 does not give you 2. 8 divided by 6 does not give you 2. Therefore, this is definitely not a GP. Okay, this is definitely not a GP. Right. So there's no common ratio. Let us see some more examples here. The first one, 2, 8, 32, and 128. So just work it out. It comes to a common ratio of 4 because 2 into 4 gives you 8. 8 into 4 gives you 32. 32 into 4 gives you 128. Now, if you look at the second example, yes, 1, then it becomes 10, then it becomes 100, then it becomes 1000. Okay. Now, what is the common ratio? Let us see all the 4 questions first. Yes. Okay. So what is the common ratio which we get? 1, 10, 100, 1000. So here the common ratio, is it 1.1? No, it is 10. Okay. So the first one, yes, definitely it is 4. The second one, 10 by 1 is 10, 100 by 10 is 10, 1000 by 100 is 10. So there is a common ratio of 10. The third one, 1 minus 1, 1 minus 1. So this is nothing but this is not progressing as such, because you see now the difference. In case of progression, geometric progression and geometric sequence, as I told you that all progressions ideally are sequences, but every sequence may not be a progression, because in case of a common ratio of -1, and the fact is what is happening, this is the number line, okay, this is the positive side, this is the negative side. So what is happening? First value is 1, second value is coming to -1, again third value is 1, fourth value comes to -1, again 1, -1. So it goes like this. This is the graphical representation when r is equal to -1. So what will happen? This is more like a wave. Okay, it's more like a wave. Okay, a wave. So does it progress? No, it is bounded. On one hand, you get the maximum value is +1, and on the other side, in the negative side, the minimum value is -1. It will not go beyond that. Even if you take, say, for example, the first term is, say, 25, what will happen? If the common ratio is -1, what will happen? It will become -25. Again, multiply it with -1, it becomes +25. Again, -25, again, +25. So it is a sequence in the sense, yes, there are numbers, but it is not a progression. Okay, because it does not progresses. It does not progress. The number is bounded. On the other hand, if you just take an example like this, say the first term is, let's take 3, and we have a common ratio of 2. So what is the sequence? 3, 6, sorry, we are taking 2 as a common ratio. Then we have 12, then we have 24, then we have 48, and so on. 3 2s are 6, 6 2s are 12, 12 2s are 40, 12 2s are 24, 24 2s are 48. Okay, so please try to understand what is sequence and what is progression. So this is a sequence, yes, because it's there is some trend, there is a trend, so it's a sequence. Okay, so I think there was one question, what is the difference between sequence and the sequence and progression? Okay, so yes. So you can understand, in case of sequence, what happens is there are numbers. Yes, there is a trend. This is a sequence as well as a progression. Why? Because it progresses. The numbers increase. The number might also decrease. Now, if you have, say, let us take the example of first term is 10. Okay, we take first term as 10. Okay, and let us take common ratio is half. Okay, 1/2. So what happens? First term is 10, the second term becomes 5, the third term becomes 5/2, and so on. So in this case, it is a reducing trend, but it is moving, it is dynamic, it is mobile. But here you see it is bounded. It is bounded in between two lines. One is +1, one is -1. Now in calculus, I don't know whether you have done calculus, this is maxima minima concept. The maximum value which this expression can take is +1 and -1. So when you have something like -1 as the common ratio, we cannot call it a progression. It's a sequence because yes, the numbers will be 1, -1, 1, -1 in this way. It will alternate. And those of you who are from the science background, you might be knowing that this is basically the curve, also known as a sine curve. This is how actually the sine curve moves. So one wave, one apex is in the positive territory, one in the negative, again positive, again negative. So when common ratio is -1, yes, it gives us something which is a sequence, but it is not a progression. The fourth one, 20, 16, 12, 8, and 4. Now this is clearly, is it a geometric progression or a geometric sequence? Let us see. Now ideally the common ratio should be equal to, it has to be equal to, it's a common ratio means it has to be a constant. Common ratio should be constant. So let us take the last example and see whether it's a geometric sequence or not. So if I take 20, 16, 12, 8, and 4, 20, 16, 12, 8, and 4, okay, 20, 16, 12, 8, and 4. Now let us take term 3 and term 2. So the ratio CR becomes 12 by 16, that is 4, 3, and 4, 4. If I take the term 1, 2, 3, 4, 5, term 5 by term 4, this becomes 4 by 8. 4 by 8 is half. That means the common ratio is not equal. Okay, in this example, the common ratio is not equal. Therefore, this is not a geometric sequence or a geometric progression. Okay. Right. So please see this slide now, and let us focus on the definition. Okay. Right. Yeah, someone is asking repeatedly, Saurav Purana, many times he's asking the same question, why we are not doing the additional questions. I don't know whether you have done additional questions or not, because this is only my second session, right? But additional questions, definitely some of them we have done, and in our previous sessions also. And also, you also need to solve it out. The point is that we are not here to solve each and every problem. It is just going to provide you with an understanding of the chapter. And of course, we are taking some easy, moderate, and difficult questions. But additional question bank, definitely you also need to take the lead and solve it, because the most important point to understand in professional courses like CA is the more you practice, the better it is. Fine. Okay. Yes, Somo, you are right. It's like a sine curve, which I was saying. Some people are asking me to explain in Hindi. Gajendra Sharma, sorry, we have to follow the rules. You need to understand English. Otherwise, the rules of the Board of Studies absolutely is very clear that we cannot use any Hindi term, whatever be the subject. Even if student asks, we cannot do it because it's part of the rules, and rules are meant to be followed. Rules are not meant to be broken. Okay. Let us take this example now, 5, 15, 45, and 135. So let us see whether we have something like, is it a GP? Well, it seems that here the common ratio is 5 into 3 is 15, 15 into 3 is 45, 45 into 3 is 135. So the common ratio is 3. Yes, it is a GP, and it increases. The second example, 1 and then half and then 1/4 and then 1 by 9. Now the question is, here of course, if you leave out the last one, 1/2, 1 by 4, 1 by 9, initially the first three, if you see, yes, it follows a pattern. So apparently the common ratio works out to half, but then 1 by 4 and 1 by 9, it does not match. So what will be your final answer? Well, so far as the second example is concerned, looking at the first three terms, yes, the common ratio seems to be 1/2. But then between the terms, term 3 and term 4, it's not working. Okay. Therefore, overall, it's not a GP. Number 3, 2 minus 6, 18 minus 54. Okay. So here again, you can see that there is something which is negative. One number is positive, the second number is negative. So here, let us take the third example and check what is the common ratio quickly. Okay. So minus 6 divided by 2. Minus 6 divided by 2 gives you common ratio minus 3. Fine. Let us take randomly 18 by minus 6. 18 by minus 6 also gives you minus 3. And if I take minus 54, which is term number 4, minus 54 divided by 18, this also gives minus 3. Okay. So therefore, absolutely correct that it is having the same CR, which is common ratio, and therefore it is a GP. Okay. So this is okay. Well, which term of the progression? Now we will look at some other examples. Which term of the progression 1, 2, 4, 8 is 256? So here we are given the nth term, which is 256. You have to find which term it is. So we will use the formula AR to the power n minus 1. And let us start solving the problems. This chapter is even simpler than arithmetic progression, just since you now know what is sequence, what is series, and what is progression. And I just explained also how, in case of a progression is a series, but it moves on and on. It will either increase or decrease. But in case of a ratio which is having a value of -1, for example, it becomes bounded. So it's a sequence, no doubt, because the number changes, but therefore it cannot be called as a progression. So in this example, 1, 2, 4, 8. So here 1, 2, 4, 8, and so on. So definitely you can see this is a GP because it follows a common ratio of 2. 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is also 2. Now we have to find, we know that the Tn is 256. Now the formula for the nth term is AR to the power n minus 1. So here A is 1, R is 2, to the power n minus 1, this is equal to 256. Okay, now just using the calculator, you can find out that here 2 to the power n minus 1 is 256. Now, if you just calculate, you will find that 256 here, it means n minus 1 comes to 8. 2 to the power 8 will give you 256, which means n minus 1 is equal to 8. That means n is equal to 9. So the answer is n is equal to 9. So the ninth term in the GP ultimately will become 256. Okay, let's take this one. Find the ninth term of the series of the sequence, 7, 21, 63. Okay. There's one question from Ronak. Ronak, no, harmonic progression is not there in the syllabus. So we only have AP and GP. Yeah, AQB, there are a number of questions. Rekha has said, yeah, there are a number of questions. So definitely you need to solve as many as possible. It all depends on how much you can do it, but you need to solve all the questions. Definitely it's going to be helpful. Okay. Okay, many of you are writing it, fine. Okay. Yeah, Mr. Om, I don't know if other faculties are using Hindi, but it's not allowed. It's as per the rules of the ICAI clearly mentioned, and we cannot break the rules. Anyone using Hindi is absolutely not following the rules, that I can tell you, because clearly it is written in the Board of Studies rules that we have to speak absolutely in English and nothing but English. Yeah, there's one question, is definition important? Yes, Miss Pinky Kumari, definition is important. You may not get a question on definition directly, but yes, based on the definition, it may not be a direct question, but based on the concept used in definition, there may be some certain questions. Okay, right. Let us carry on. So if we start answering each and every question, still I'm trying to answer as many questions, but we get delayed. And the purpose is, of course, it's not a question answer round, or it's not a doubt clearing round, right? There might be some extra sessions for that, but definitely this is not the forum for that. So we have to go on with the discussion and not get diverted with the questions, because thousands of questions are coming. So find the ninth term of the geometric series 72163. Please follow it, right? And for the time being, forget on the questions. First, you understand, then ask question. Some people are just asking questions which have no meaning or which are not concerned with the topic. So try to remove all those things from your mind. Focus first on learning, understanding, practicing, and then asking questions. Okay, now find the ninth term of the geometric sequence 7, 21, and 63. So this is clear. So we can see that there is a common ratio of 3. As simple as that. 7, 21, 63. 7 into 3 is 21, 21 into 3 is 63. Therefore, the common ratio is 3. We have to find the ninth term. Okay, so term 9, T9. So T9 will be what? T9 is AR to the power n minus 1. AR to the power n minus 1. Here A is 7, R is 3, and n is 9. So it becomes 9 minus 1. That means 7 into 3 to the power 8. Try to work it out and see what it comes to. So here the first term is 7. Common ratio we have seen is 3. And therefore the formula is 7 into 3 to the power 8. And just try to use a calculator and work it out. This will come to 45,927. Let me just quickly check. Yes, many of you have got it. Yeah, many of you have got it. Yes. So Akanksha, Mohak, yeah, Ria, Venom, Siddhartha. Yes, okay, fine. We see another example, and now it will be the summation. We also learned the summation now. So the second formula we have to learn in this chapter is summation, how to find the sum of a geometric series or a progression that way. So the summation formula is given by Sn. First term is A, so we write A. Now if R is less than 1, R can be a ratio, can be a fraction. So if the common ratio is say a fraction, say 1/3, 1/5, 1/10. So if R is less than 1, that it becomes a fraction. In that case, we will use the formula A 1 minus R to the power n divided by 1 minus R. If R is less than 1. And if R is more than 1, okay, if R is more than 1, then it will be just, so this is R is less than 1. But if R is greater than 1, it will just become opposite. So instead of 1, we will write R to the power n, and instead of R to the power n, we will write 1. Here also we will change R minus 1. Okay, as simple as that. So it will become A into R to the power n minus 1 divided by R minus 1. Okay, so this is how we follow the rules. These are the two basic rules. One is for the nth term, and the other is for the summation. Okay, so now you are familiar what is common ratio, what is first term, finding the nth term, and then we find also the summation. There are two formula, basically one formula, but two shapes, two types you can call it, depending on whether R is less than 1 or whether R is greater than 1. Okay. Okay. Now let us see this one. Find the 10th term in the sequence. 1, minus 6, 36, and minus 216. 10th term you have to find. In this sequence, 1, minus 6, 36, and minus 216. So let us try and work it out and see what the results are. Here you can see the first term is 1, and the common ratio is minus 6. So just by applying the formula, common ratio is minus 6. Therefore, the formula becomes A10, that is 10th term we have to find. So in this example, the 10th term is calculated like this. The formula is ARn minus 1. So here A is 1, R is minus 6, N is 10. So it is to the power 10 minus 1. So it is 1 into minus 6 to the power 9. So just you have to use the values and it should come to 1 into minus 6 to the power 9. So just a little bit of work on the calculator and you can get the answer. Okay, now we come to geometric mean, which is 6.5, chapter 6, 6.5. We are strictly following the study material and the sequence given in the study material. And you see, this is absolutely for each of the chapters, you know, even for accounts, even for law, we have to first understand the concept. We cannot jump only to the answers, questions and answers. We cannot do it. We have to complete the understanding of the lesson first, each of the formula, each of the concepts, right? If I quickly jump to the questions from AQB, it will become meaningless because many of you will not be able to follow. So that is a wrong process, okay? Now, geometric mean, if ABC are in GP, we did a problem close, very similar to this in the last session. Now, if ABC are in GP, well, if ABC are in AP, just remember if A, B, and C are in AP, what is the result? What is the result? The result becomes A plus C will be equal to 2B. Or we can use, this will provide us with B equal to A plus C by 2. This is when it is in AP, when it is in arithmetic progression. But when we are speaking of GP, which is geometric progression, the thing will change. But it's not going to change drastically. Here, GP means we will use the simple concept. If A, B, and C are in GP, then the geometric mean will be calculated like this. B will be the geometric mean, and the formula is very simple. B by A will be equal to C by B. And this is nothing but the common ratio. B by A has to be equal to C by B. Here, B is the second term, C is the third term. So the second term divided by the first term, B by A, has to be equal to the third term divided by the second term, it is C by B, right? Therefore, we get a common ratio. And if you just multiply, we get B square. Cross multiplying, we get B square equal to AC. Therefore, of course, B will be plus minus square root of AC. Okay, so this is how we calculate the geometric mean between A and C. This is the theory. Yes, we will take number of practicals. Here we start with the examples. Insert 3 geometric means between 1 by 9 and 9, right? So we are trying to take number of problems, at least 20, 25 problems we have done in AP, also we are going to do in GP. Many of these questions are similar to the questions which you will find in the AQB. Also, mathematics is such that we cannot complete entire, if there are 60, 100 problems, we cannot do it, but we will try to do 15, 20, 25 problems so that it becomes a sample of the entire population. And rest, you have to use your brain, you have to use your mind, look at the solution, go through the videos once again, go through the chapter once again, because mathematics is all about doing it yourself, right? You follow the trend, follow the examples, and then try to solve it. Right, let us take the first question here, and let's understand 3 geometric means between 1 by 9 and 9. That means there will be a situation like this, 3 geometric mean. So 1 by 9 is here, and there will be 3 terms, and then you have 9. So from this, you can understand 1 by 9 is the first term, second term we don't know, third term we don't know, fourth term we don't know, but the fifth term is 9. So this is what we have to find. So in other words, we can write this 9 is the term 5, term number 5. So the question is, we are familiar with the formula A r to the power n minus 1. Here A is how much? A is 1 by 9. R we don't know, and n we know, n is 5. Okay, so what we get is R, n is 1, 2, 3, 4, 5. So 5 minus 1, this is equal to 9. First term is 1 by 9. Common ratio is r to the power 5 minus 1 because here n is equal to 5. First term, second term, third term, fourth term, and fifth term. So n is 5. So 1 by 9 into r to the power 5 minus 1 gives you 9. From there, if you find out the value of r comes to 3. So if r is coming to 3, then definitely we can get the first 3 geometric means here, which we need to find out. So the first GM will be how much? First term is 1 by 9. The common ratio is 3. So therefore, this number will become 1 by 9 into 3, that is 1 by 3. So I put 1 by 3 here. The second number will be 1 by 3 into 3, which becomes 1 by 3 into 3 becomes 1. So I put 1 here. And then the next number which you see, that is the third GM, will be 1 into 3, that is 3. So the 3 geometric means which we are putting, which we are inserting between 1 by 9 and 9, we have found out. Here the common ratio is 3, and we are using the simple formula t to the power tn equal to a into r to the power n minus 1. This is how we are able to solve this problem. I hope it's clear, and we are not only looking at the slides, but also I'm sure we can check this. Yes, many of you have got it correct. Okay. So we move on. Find 2 geometric means between -2 and 54. -2 and 54. Now let us try and do this. Okay. So one problem we can check, we can understand. But if every problem I solve, then what happens? You will not be able to develop your processing power. You will start memorizing. Mathematics is not about memorizing. Mathematics, logical reasoning is about applying. You see one problem, learn, right? Many of you know artificial intelligence. What does an artificial intelligence system do? It looks at certain problems, understands the way, then starts developing the pattern in the mind so that it can do it next time. That's how human intelligence works. Okay. So this is not about memorizing the steps, or not at all about, thinking that, oh, if I do 100 problems, all questions will be common and so I will get good marks. No, it's all about understanding, analyzing. That's how mathematics works. And later on, you'll find even accounts, even financial management, costing, every subject is like that. So let's see, find 2 geometric means between -2 and 54. So 2 geometric means, that means -2 is here. There is one geometric mean, another geometric mean, and then we have 54. Okay, so the first term T1 is 2. First term, second term, third term, fourth term. T4 is equal to 54. We don't know the value of R. So what to do? Let us try and find out what can be the value of R here. Okay, so we use the formula T4 equal to 54, where A, the first term, is -2. So the formula is -2 R to the power n minus 1 equal to 54. So this means, this boils down, once again, you can see A1 first term, An is the nth term, n is the number of terms, okay, and common ratio, of course, is R. So here we can see that R comes to -3. Okay, R comes to -3, and therefore, if we look at, just a sec, yeah, -2 R to the power n minus 1. Just a sec. Okay, R comes to -3. Therefore, we can see that the other terms, since we are starting with -2, so we can check that -2 into -3 will become 6, and 6 into -3 will become -18. So this is 2 GMs included between -2 and 54. Okay, now let us take the next one, and the sum we have already checked when R is less than 1, and the sum when R is more than 1, the summation formula. So one more example, we can see the first formula in the first box. You can see Tn equal to A into R to the power n minus 1. And the next formula we can check is Sn equal to A into R to the power n minus 1 divided by R minus 1. And please remember, this formula is valid when r is more than 1 and when r is less than 1. When r is less than 1, you can understand that it will be, just remember, please try to check the common ratio. Otherwise, you will not be able to find out. Kindly check the common ratio. If the common ratio is more than 1, if CR is more than 1, then always use the formula Sn equal to A into r to the power n minus 1 divided by r minus 1. And when you see that r, that is the common ratio, is less than 1, say it is 0.5, it is 0.7, it is say 1 by 6. So you know that this is a fraction, that means it is less than 1. In that case, we have to just change the formula. This formula will not work, and therefore it will give a wrong result. It will give an inconsistent result. So in that case, please remember, when r is less than 1, we will just change the sequence. It will become 1 minus r to the power n. In the denominator also, it will become 1 minus r. So it will just change according to the structure of the, that is the value of the common ratio. Now, there could be something like a infinite geometric series. Now, typically when you see that GP till infinity. Now, it's a very small ratio, a very small term which you need to know. Say, for example, something like, let us take, say, a ratio of, say, half. Okay, and the first term is, say, 4. So 4 is the first term. So the next term will be 4 into half, that is 2. Okay, the third term will be 2 into half, that is 1. Then it will become half. Then it will become 1 by 4. In this way, if it goes on till infinity, that means there is no end, infinite series. In that case, the simplified formula which we have to keep in mind is S infinity is equal to A divided by 1 minus R. Okay, so in case of an infinite series, S infinity will be equal to A into 1 minus R. So this is an infinite series, infinite GP series. You will also use the same formula when you go for the chapter on time value of money, especially in compounding. You will use the same formula. And also in the case of bond valuation, which is included in the chapter on time value of money, the same principle is followed, infinite GP series. But always remember, infinite GP series formula A divided by 1 minus R is only valid when R is less than 1. Now, if R is more than 1, it will have a very unconventional outcome, because in that case, if R is more than 1, then what will happen? Say if R is 3, then what will happen? It will be undefined. Okay, so in case of R more than 1, there is no formula. R has to be always less than 1. Yes, in that case, there can be a sum of infinite GP series, and questions in the exam obviously comes from this formula, that is infinite GP series. Okay, so when R is less than 1, then the infinite GP series will become like this. So you know this is the sigma sign, sigma. So summation A R I, and therefore it reduces to, it simplifies to A divided by 1 minus R, where A is the first term and R is the common ratio. And as I said, if R is more than 1, or R is a modulus, if R is greater than or equal to 1, well, in that case, series will not have any sum. So this is, we are trying to find the sum, and it becomes a series because it's a sequence, and we are finding the sum of the sequence, each of the terms, so it becomes a series. Right, so we take the first example. This is an infinite series. It seems this is an infinite series. Okay. Yeah, there's one question, which book to follow? Well, study material, I cannot suggest any other books. We have to follow the study material. It is quite in-depth. It has number of questions, examples. You have the exercises, you have graded questions. You also have the AQB, you have the mock test paper, and also you have number of chapters which are included in the referencer. Of course, referencer does not include all chapters of your syllabus, but yes, it includes many of the important chapters like probability, like time value of money, okay, and also ratio, proportion, and other chapters which are important. Rest you can definitely go through the mock test paper, which completes, which is nothing but the entire, it's a revision. If you do a mock test paper, it will provide you with a complete revision of the entire curriculum, right? And definitely practice manuals are also available on the site, and that's why I shared the links. And please go through the CA student newsletter, because every 2-3 months you will find, in fact every month, one particular chapter is dedicated to CA Foundation. It can be on economics, it can be on business commercial law, it can be mathematics. Like I think the latest issue, if you check the August issue, there is, I think, quite a good number of problems from business mathematics. So if you go on checking the last 1 year, I have shared the link for the complete list. If you look at the archives of the student journal, you will find number of questions, answers, almost on every chapter of business mathematics and statistics. Okay, so let us take this example, 3 plus 0.3 plus 0.03, and it goes on. It seems to be an it's just like an infinite series. So what we do is we can easily check the common ratio, and let us try and solve this. We can have a look at the common ratio computation, and then we will try to solve it. Now the question is 3 plus 0.3, 0.3 plus 0.03 plus 0.003, and so on. So it boils down to 3 plus 3 into 0.1, because 3 into 0.1 is 0.3, plus we can write 3 into 0.01. And if this is the answer, 3 into 0.1 to the power square and 3 into 0.1 to the power cube and so on, what will happen is this becomes like an infinite series. So therefore, it can be seen that the common ratio is 0.1. The common ratio is 0.1, and therefore this will be an infinite series, and it will take up the value of it will take up the value A is 3 and the R is 0.1. So therefore it's an infinite series. S infinity, if you take, this will become A 1 minus R, that is 3 divided by 1 minus 0.1, and then you can work on it. So it comes to 0.9. So it is 3 divided by 0.9. 3 divided by 0.9, that is 9 by 10. So it is 3 into 10 by 9. Okay, so 3 into 10 by 9, that means 3 and 3 cancels. It is 10 by 3, that is 3.33. The next one is here 3 minus 1 plus 1 by 3 minus 1 by 9, and so on. We have to find the sum. So looking at the it is a series, of course, because already the symbols, minus and plus symbols, the signs are included. So we have to find the sum. The problem clearly mentions. Now here it seems that the common ratio, let us work out the common ratio in this example and check what is the common ratio. Now in case of common ratio, 3 minus 1. Now that means we can write that term 2 divided by term 1. What is the second term? The second term is minus 1, and the first term is 3. So term 2 by term 1, therefore common ratio is minus 1 by 3. Right. Now this is an infinite series because they have not mentioned in a problem like this. If it is mentioned in the question paper that find the sum till say 20 terms, till 15th term, till 30th term, well, then it's easy. You can find out till 7th term. It's a finite number. Since nothing is mentioned, we are assuming therefore that we have to find, it's an infinite series, and therefore we have to find the sum of the infinite GP series, because there is nothing mentioned in the problem regarding the number of terms up to which you can find the sum. So in this case, we use a very simplified formula, which we have already explained. S summation, that is sum of the infinite series, equal to A divided by 1 minus R. So here the value of R comes to minus 1 by 3. Please note that this is r is less than 1. That is the qualifying requirement. If r is more than 1, then the formula will not work. It will not have a sum. Now r equal to minus 1 by 3. So therefore a is 3. A is 3 because a is the first term. Therefore the sum to infinity is equal to a by 1 minus r. That means it means 3 divided by 1 minus r. R is minus 1 by 3. 1 minus minus 1 by 3. So it becomes 1 plus 1 by 3. It becomes 1 plus 1 by 3. That is, it becomes 3 divided by 4 by 3. 3 divided by 4 by 3. And now you can solve it. So 3 divided by 4 by 3, and therefore it comes to 9 by 4, which is the answer to the question. Of course, it's an approximation. Please remember that since we are creating infinity is a journey, it's not a destination. We are not, infinity means going on and on. It's dynamic, it's not going to stop. So now you may remember, you may think, how are we getting a number like 9 by 4? Well, when you look at the formula of GP, now as n tends to infinity, right? As n, the number n, the term, number of terms n moves towards infinity, what will happen is there will be certain changes and approximations which we have to do, and therefore what happens is we are just getting the formula a divided by 1 minus r. Okay, the reason is that once we increase, once it goes on, once n tends to infinity, not naturally in the formula which we have, s is equal to a into 1 minus r to the power n by 1 minus r. So what happens is, as n tends to infinity, as n becomes bigger and bigger and bigger, so what will happen is ultimately this value approximates to a divided by 1 minus r. Okay. Now let us see more examples. Find the sum of 1 plus 2 plus 4 plus 8 up to 8 terms. This is a fairly simple question, and just try to solve it and check. Okay. Just try to solve it and let us see. Yes, too many of you got the right answer correct. Yes, Ravinder, I explained that r cannot be more than 1. For infinite series, r has to be always less than 1. It is by definition of mathematics. Okay. 2.3, many of you got correct. 2.4, 2.3, 9, yeah, Miss Mitra, then Pragya, Chandan, Anjana, Rajashri, also Venom, Lakshya Gupta. Yes. Okay. Lakshya, you were asking for a break, but I'm sorry, we have to go non-stop because a lot of things are to be done, and I'm just doing it so that you get the maximum benefit. Last day also we went beyond 4. The objective is to give you as much of practical problem solution as possible. Normally, if you want to take a break, you are most welcome, but we shall continue. Okay. Find the sum of 1 plus 2 plus 4 plus 8 up to 8 terms. Okay. So here it's mentioned it's still 8 terms. Now, what is the common ratio? Common ratio here is 2 by 1, which is 2, 4 by 2, which is 2. So common ratio is 2. So safely we can write common ratio is 2. We have to find the value till 8 terms. Also, please note common ratio is more than 1. The ratio is 2. That means it is more than 1. So which formula we shall be using? We shall use the formula Sn equal to a r to the power n minus 1 by r minus 1. Here a is 1. So I write 1 here. R is 2. So 2. We have to find the value till n. So n is 8. So I'll write 2 to the power 8 minus 1 divided by 2 minus 1. 2 to the power 8, just calculate. So you will see that it comes to 2 to the power 8 minus 1, which is 256. Okay, so 256 minus 1, which is 255. So answer is 255. Okay. 2 to the power 8 minus 1 divided by 2 minus 1. So this is a simple one. Let us take example 2. I'm taking some of the examples in the study material also. Find the sum to n terms. So 6 plus 27 plus 128 plus 629 and so on. Okay, 6 plus 27 plus 128 plus 629. Okay, so if you see, this is a bit, this is not a direct question. It's a bit tricky. So you have to break up. Okay, so if you look at these numbers, this will be useful because similar concept we shall be using when we go into logical reasoning. Okay, in logical reasoning also we have to understand the analysis of different numbers and to break different numbers. So here the same concept, 6 plus 27 plus 128, we can break it into 5 plus 1. 27 can become 25 plus 2, so it becomes 5 square plus 2. 128 will become 125 and 3, but 125 is 5 cube. So if you break up the entire expression which is given, what are we getting? We are getting two different series. Okay, so 6, if you break up, okay, so we are getting 5 plus 1, then we are getting 5 square plus 2 plus 5 cube plus 3 and so on. So if I take 5 square, 5 cube together and 5 to the power 4 and all, so we will be getting certain terms, certain numbers, and we will take till n terms because the question clearly says find the sum to n terms. So the first series becomes 5 plus 5 square plus so on till 5 to the power n. And in the second series also we are getting 1 plus 2 plus 3 up to n terms. Now, the second part we have done last day, which is, this is an arithmetic progression. And here in the first case, what we see, this is a GP because here there is a common ratio of 5. So for the first part, we take the value a r to the power n minus 1 divided by r minus 1. Why we are taking this formula? Because here r is 5 and 5 is more than 1. The requirement is if r is more than 1, we will take this formula, right? Therefore, we take 5 as the first term. A is 5, r to the power n minus 1, r is 5, 5 to the power n minus 1, divided by r minus 1, that is 5 minus 1. This is the first part. And the second part becomes very simple. It is the sum of the first n natural numbers, and we know the formula is n into n plus 1 by 2. So we get the solution to this question. And then you can simplify, of course. Right. Example 6, page 6.13, find three numbers in GP whose sum is 19 and product is 216. Okay, we will also take number of exercise questions, but let us start with this. Already we have started with the solution to practical problems. Three numbers in GP whose sum is 19 and product is 216. Okay. Yeah, many of you got. Yeah, this is a mixture. Yes, Mohak, you are right. This is the last question is a mixture of GP and AP. And you may get this type of question. Also 255, many of you got correct. Great. So Ansh, Sulbhi, Sandhya, Yash. Okay. Then Karan. Yes, very good. Very good. Okay. Find three numbers in GP whose sum is 19 and product is 216. So we shall try to take the numbers in GP and we will take three numbers in this way. So let the three numbers be A by R, first number. Next is A and the third is AR. So you can see A by R, if you multiply with R, which is the common ratio, you will get A. And if you multiply A with the R, that is common ratio, you will get AR. So let us take these numbers. Their sum is 19 and their product is 216. Okay, so let us try to find the product. So first of all, the sum is 19. Sum is 19. Okay, fine. And their product is 216. So let's find the product. A by R into A into AR. R and R cancel, so we get A cube equal to 216. If A cube is 216, then you can easily find out A is equal to cube root of 216. Cube root of 216, I think this will come to 8. 8, just check. No, this is going to be 216 for, just check. 216 cube root, 6. 6 into 6, 36. 36 into 6, I think we will get 216. 36, 6. Yeah. So cube root is coming to 6. So now we know that these numbers which we have taken A by R, A and AR, these are basically 6 by R. 6 by R. A is 6 and AR is 6R. And the sum is 19. Okay. So now it's a question of quadratic equation. So let us just check. So we have taken the three numbers A by R, A and AR. According to the question, A by R into AR, that is the product is 216, and therefore from there we have easily we have been able to calculate that it comes to A is coming to 6. So since the sum of these three numbers is equal to 19, so we are adding up these three numbers, and let me do it along with the solution which I have given in the slide. Let's try and do it. 6 by R plus 6 plus 6R, this is equal to 19 as per the problem which is given. Okay, therefore what do we get? So I can write 6 by R plus 6R is equal to 19 minus 6. So that will give me how much? 13. Okay, 13. Now it's a question of quadratic equation. So if you just take R here, we get 6 plus 6R square, which is equal to 13. 6 by R plus 6R. Okay, 6 by R plus 6R, it simplifies to 6 plus 6R square by R, which is equal to 13. Now we have to use the concept of cross multiplication. So we are using cross multiplication and we are trying to get the quadratic equation. So the cross multiplication, if I do, then I'm getting 6R square plus 6 equal to 13R. In other words, by transposing, I am getting 6R square minus 13R plus 6 equal to 0. This is the final quadratic equation. So you can see that the question is basically GP question. Now, why have I taken this question for solution? Why did I take the last question? There's a reason. I have not done it randomly. The reason is the last question which you remember where I broke up each of the terms. That was one of you also wrote that is it a mixture of AP and GP? Yes, it's a mixture of AP and GP. That is why I took it for the analysis and make you understand. This question I have taken purposely. There is a reason behind selecting every question. This question is unique because it contains an application of not GP only. There's a quadratic equation. So if such a question comes in the exam, you need to demonstrate your knowledge. You should be having perfect knowledge, not just in using the formula of GP, but also solving quadratic equation. Otherwise, you will not be able to reach the final answer. Okay, so therefore here you see it's absolutely a quadratic equation, 6R square minus 13R plus 6. So what can we do? So if you break it up, what will happen? 6R square minus 13R plus 6 equal to 0. So let us take this as we can break it up as 4 and 9. So we can take 6R square minus 4R minus 9R plus 6 equal to 0. So if I take 2R common from here, I get 3R minus 2. And from here, if I take 3 common, I get 3R minus 2 equal to 0. So the two roots of the quadratic equation, this is the quadratic equation. The two roots which I'm getting, one is 3R minus 2 equal to 0 or 2R minus 3 equal to 0. 2R minus 3 equal to 0. So these are the two roots of the quadratic equation which we are getting for this particular question. Now comes the issue. If you see once again, what is the question? What does it ask? So we have to find the numbers. So we need to find R. We know that A is equal to 6. Perfect. So we have to find R. Now, if 3R minus 2 equal to 0, the first option, then we can write that R has to be equal to 2 by 3. And if I take the second option, 2R minus 3 equal to 0, then R has to be how much? 3 by 2. Okay, so we are getting two values of R, 2 by 3 and 3 by 2. So therefore, the numbers can be like this: 6, okay, 6 by R, first number. Next is 6, third is 6R. Just put R equal to 2 by 3 here. So what do we get? 6 divided by 2 by 3. That means 6 into 3 by 2. So 2 3s are. So it can be 9, 6, and 6 into 2 by 3 is 4. So it can be either 9, 6, and 4, or if you take the other number, it will be 4, 6, and 9. Okay, so virtually it's the same set of numbers. One is having one is having a ratio less than 1, 2 by 3, and if you have a ratio more than 1, you are getting 9, 6, and sorry, if you have a ratio less than 1, you get 9, 6, and 4, and if the ratio is more than 1, you get 4, 6, and 9. Okay, so this is an important problem which we completed, which is a mix of both quadratic equation, getting the roots of the quadratic equation, as well as using GP formula. Okay, now we will take this question. A person is employed in a company at 3,000 per month, and he would get an increase of 100 per year. Find the total salary he received in 25 years and the monthly salary in the last year. So let us check what type of question this is. 100 rupees per year. Okay, so he's getting 3,000 per month and he's getting an increase of 100 rupees per year. That means 3,000 in the first year, every month, 3,000 into 12. In the second year, this will become 3,100 into 12. Okay, so we have to find out the monthly salary in the last year and also the total amount which he received in 25 years. So here n is 25. Fine. So therefore, the equation will be like this. Now, we can understand that here the question is, this is an AP question. So I'm taking some revision questions on AP as well, apart from GP. Since today is the last session on AP GP, we are also taking some questions on AP. So if you look at this problem in this question, yeah, Dharmender is asking, how can we solve all questions because there is a limit of paper and time? Well, there is a limit of time, as simple because the question is, you have to do time management. The more you practice, which I was mentioning last day, the more number of questions you practice under exam conditions, the better it is. The virtual coaching classes are giving you complete understanding of every chapter. Yes, it is true, even in other subjects, whether it's IPCC or final, we cannot solve all questions, and it is not the purpose also. The purpose is not to spoon feed everyone. The purpose is to show what the chapter is all about, make you understand the key concepts, complete the important formula, analyze the type of questions, and then definitely you have to do the major work because you will have to appear for the exam. So from the institute side, we are doing everything possible to make sure we are guiding you for the exam. But how many hours you are going to study every day, or how many number of questions you do every day, that is entirely your, how you look at CA. CA is a professional course. You are joining the CA course, which is the best course in the field of finance, commerce, taxation, accounts, and audit. Fine. And ICAI is a truly global organization. So the idea is to bring out world-class accountants, world-class chartered accountants, which means you have to practice right from day one. And the more number of problems you do, you will develop three things. First is confidence. You will develop accuracy, which is important. You will develop time management. So more problems has to be solved. Please don't rely only on the problems which we are doing. Right, we are trying to take the most critical questions. We are taking the most important questions from the trend which we have got from the last few years, but then try to practice solving the questions under exam conditions. Here, I am taking a lot of time to solve each of the questions. Why? Because my objective is to not to do it fast. My objective is to make you understand. So even though the answer and the working out is given in the presentation, I am still trying to solve it so that you know the step-by-step analysis. Right, but this is not. I am doing it at a relaxed manner so that you can understand. In the exam, you have to do it fast. What is this? What is the key to success? More and more practice. Solving as many MTPs as possible, solving as many types of problems as possible under exam conditions. So you have to look at the watch. What is the average time? What is the total amount of marks? And what is the allotted time? So from there, you can find out what should be the maximum time to solve a particular question. Also, some of the the questions carry negative marks. So you have to be careful to take those questions which are where you are sure, which you know. And the difficult questions you can keep to be solved later. So that's how you have to scan the question paper, and maybe you can start with logical reasoning, which is the easiest part, then go to mathematics, complete some of the easier chapters, and then focus on the more difficult questions. Okay, so definitely you can complete 100 marks, no question about it, no doubt. But then it means planning. CA is all about planning and consistency. Okay, so this is just the starting. Go through the VCC, solve the questions, and try to see your solution with the given answers, see your accuracy percentage, and slowly over the next few months, you will definitely improve your speed, confidence, and you will be in a position to tackle 100 marks, not a question, definitely. Now let's come back to the question in the last year, what will be the salary? Now every year, you can see 3,000 is the salary in the first year. Fine. Next year, the salary becomes 3,100, then 3,200. So I can take the formula of arithmetic progression and I can say that this is an AP question. And here the first term A is 3,000. Okay. And the increase in the salary, which is the common difference, CD, is equal to how much? 100. 100 every year. It is increasing. Okay. So the salary increases by 100. So the final salary in the 25th year, okay, will be by the formula A plus N minus 1 into D. So here A is 3,000 plus N minus 1. N is 25 minus 1 into D. D is 100 rupees. So if you work it out, I think you will be getting 25 minus 1 is 24. 24 into 100 is 2,400 plus 3,000. So it becomes 5,400. First part is done. Now, what is the final, what is the total salary, total amount which he earns? So total amount is very simple. First year, he earns 3,000 into 12. Second year, he earns 3,100 into 12. Third year, he earns 3,200 into 12 and so on. So the total amount is nothing but what you see in the slide. You take 12 common, 3,000 plus 3,100 and so on, and it reaches still 5,400. So this absolutely comes to 3,000 plus, if you take a complete, if you just simplify this expression, what we get is final answer comes to 12,60,000. So just a question of just try to take common and you will be achieving 12,60,000. So this is the total amount. Just check the working out. This is the total amount of salary which the person will be earning in 25 years. The next question, a person borrows 8,000 rupees at 2.76 simple interest per annum. The principal and the interest are to be paid in 10 monthly installments. Okay. If each installment is double the preceding one, find the value of the first and last installment. So here the principal amount which is borrowing is 8,000 rupees. Simple interest is 2.76 per annum. Please see it is per year. And the total amount of monthly installment is 10. So here N is 10. Now, if the installment, each installment is double of the preceding one. So if the first installment is X, the second installment becomes 2X, the third installment becomes 4X. It doubles. So we are just multiplying by 2. So definitely what we have to find out the first and the last installment. Okay. So let us try and solve it. Now, how much are we going to pay as interest? Because this has to be paid in 10 installments and this is 10 monthly installments. Okay. So first we find out the total amount of interest. Interest which is to be paid is, just let us work out on the interest. Now, this is also a very, very interesting question and quite a, this is definitely going to be an interesting one, and the working out is also done step by step. So first we find out what is the total amount of interest which you are paying, which you have to pay. So the amount is 8,000 rupees. So 2.76% for 1 year into 8,000. But you are paying it for 10 months because you are completing the entire repayment in a time of 10 months. So it will be into 10 by 12. Just let us check 2.76 into 10 by 100 into 8,000 by 12. So it comes to 184. This is the total interest. And therefore, the total amount which you pay is how much? The principal amount was 8,000 and you are paying 184 as interest. So you are paying 8,184. So this is the total amount you are paying, right? So I can now use something like the GP, okay, because it is given in this problem that every installment is double of the first installment. That means the common ratio is 2. The common ratio is 2, and the number of n is 10. And we know the sum is what we have worked out, 8184. Kindly note, once again, I am giving you the reason why I took this question. There is a reason behind every question I have selected. This question is not just a question on AP or GP. It also includes, this is how you see the Board of Studies prepares each of the question. They put so much of thought into it. They put so much of their mind into it, so that we are able to have certain questions which involve applications from 2 chapters. Like we saw, one application was from both AP and GP. One application we took where it was quadratic equation as well as GP. This one I have taken up, not arbitrary. It's not like I have just taken randomly, okay, we have to do few questions, chalo, let's do it. No, that's not the way. So I have taken these questions carefully, looking at the nature of the question. This question I have taken because there is an interest calculation, and many people will make mistakes in the interest calculation because it is basically per annum, but the duration is 10 months. So you have to be very careful. Then you have to find out the amount. Amount is principal and interest. So this is nothing but an application of GP chapter as well as time value of money. This is the reason why I've selected this. Okay. So please, I hope you're able to follow that the questions I'm taking up for analysis is not of the same type, all different types, and they are based on different focus areas. Yes, the common point is GP, no question, but then GP with quadratic, first combination. Second combination was GP and AP. The third combination is GP with interest. Okay, so here 8184, fine. Number of installments 10. We don't know the first installment, we don't know the last installment, but we know the common ratio is 2. Now here we have seen that the summation is 8184. We know summation is equal to the sum of a GP progression is equal to A into R to the power n minus 1 by R minus 1. Now this has to be equal to 8184. Now A we don't know, R we know, n also we know. Now if I just simplify the terms now, just write it here. Since A we don't know, so A I don't know, okay. R is how much? R comes to 2. So 2 to the power 10 minus 1 divided by 2 minus 1. This is equal to 8184. So if I equate in this way, I get A. A is the first installment. So it's a lovely question from the Board of Studies. Definitely you will get A comes to 8. Okay, so the first installment we can get. And therefore the last installment, if I get the first installment, I can also get the last installment. Okay, so therefore we know that the nth term is given by Tn, which is AR to the power n minus 1. Here A is coming to 8, R is 2, and n minus 1, n is 10. So n minus 1 becomes 9. So the last installment will be 8 into 2 to the power 9. So it comes down to 4096. So this is the solution to the problem. The first installment and the last installment we have found out, but please kindly note that this question is not a simple question. It is based on interest calculation. It combines GP with time value of money. Okay, this is an easy one. The fourth term of the series, 0.04, 0.21, and so on, is how much? So I think you can see that the common ratio comes to 0.2 divided by 0.04, which is 5. And the first term is given 0.04. So therefore, the fourth term definitely comes to 5. Okay, just I'll solve it in case you have not followed. Okay. Yes, many of you got it correct. The paper pattern, okay, Mohak is asking about paper pattern. Paper pattern, I will take it up later. I'm just noting it. The paper pattern for the exam, I will take it up in a subsequent session, because today we are almost, we don't have extra time to discuss. We will have to complete number of other problems. We have already started doing so many problems, and let's take this one. See, the first term is A, which is 0.04, and the fourth term we have to find out. Okay, so therefore term number 4 is equal to ARn minus 1, that is A is 0.04 into R is 5, so into 5, and we have to find the fourth term. So n is it comes to n is 4, so 5 to the power 4 minus 1. So this boils down to 0.04 into 5 to the power 4 minus 1, that is 3. 5 to the power 3, that is 5 cube is how much? 5 into 5 into 5, that is 125. So I can write straight away 125 multiplied by 0.04. So that comes to 5. Okay, so answer is 5. The next one, exercise 6B, number 11. The second term of a GP is 24 and the fifth term is 81. What is the series? Answers are given, options are given. Let us try and work it, and then we will match it with the solution which I have prepared. Okay, fine. Many of you got it. Well, how many questions are asked in the exam? There is a question from, I think, yes, Pulakanti Praharshita. The question is, how many questions are asked in the exam? Well, it's for 100 marks. So definitely there could be a situation where you may get 100 questions. You may also get less than 100 questions. Maybe certain questions will carry 2 marks, but on an average, it's always 100 questions, 100 marks. Each question carries 1 mark, and you know the focus is that 40 marks will come from business mathematics, 20 marks is going to come from logical reasoning, and the remaining 40 marks is going to come from statistics. So question number 1 to 40 is usually, I'm saying the pattern is 1 to 40 is absolutely on business mathematics, 41 to 60 is on logical reasoning, and 61 to 100 will be on business statistics, the statistical part. Okay, that's how the questions will come. Okay, right. Now, the second term of a GP is 24 and the fifth term is 81. Okay, second term is 24 and the fifth term is 81. Let's try to work it and see. So let us take the first term as A and the common ratio as R. Okay, so A and R. Now the second term is 24, A and R. Second term, term 2 is A R n minus 1, that is A into R into 2 minus 1, that is AR. That is 24. We have got it. The fifth term is 81. Fifth term is T5, that is A into R into 5 minus 1, that is AR to the power 4. This is 81. So we have got the answer directly. If you just divide T5 by T2, T5 by T2, you are getting AR to the power 4 by AR. So A cancels, R cancels, you get R cube is equal to 81 by 24. This is what you're getting, R cube is equal to 81 by 24. So this will go by 27, and this is 3 8s are 24. 27 by 8. 27 by 8 is a beautiful number. It's nothing but a cube. So R cube is 27 by 8. So R is how much? Cube root of 27 by 8. 27 cube root is 3. And 8 cube root is 2. So I can get R is equal to 3 by 2. If R is equal to 3 by 2, then I can just use R equal to 3 by 2 in this equation. I can just write A into 3 by 2 is 24. So let me write A into 3 by 2 is 24. Therefore, A is equal to 24 into 2 by 3, that is 16. I'm getting the answer 16. Therefore, A is 16 and R is 3 by 2. So you can, the question is what? What is the series? So you can easily find out the series now. So A is 16 and R is 3 by 2. So the series has to be 16, then 16 into 3 by 2, that is 24. Then 24 into 3 by 2, that is 36, and so on. So 16, 24, 36. I think option C should be the right answer. Let's just work it out and see whether we have done it correctly. So R comes to 3 by 2, A is 16, and therefore 16, 24, 36. So we have done it correctly. Exercise 6B, number 13. In a GP, the product of the first 3 terms is 27 by 8. What is the middle term? Okay. The product of the first 3 terms is 27 by 8. What is the middle term? Let's try and do it as simple, in a simple manner as possible. Okay, just try and do it. Yeah, 11th question, what you are saying, we can do through eliminating other options like one option C. No, ideally, don't go for elimination, Ravinder. It's better to solve it out. Of course, if you are pressed for time, then you can use elimination of the options, but ideally, it's better to work it out. Okay, now in a GP, the product of the first three terms is 27 by 8. So let the GP be like this, A by R, A and AR. So the product is 27 by 8, which means this is 27 by 8. So straight away R and R cancels. A cube is 27 by 8, which means A is 3 by 2. What is the middle term? So we wanted to know the middle term. Answer is 3 by 2. Solved. Okay, clear. Okay, I hope you have followed it. Now moving on to the next question, exercise 6B number 17. The sum of the first 20 terms of a GP is 244 times the sum of its first 10 terms. What is the common ratio? This is we have to just understand. The sum of the first 20 terms of a GP is 244 times the sum of its first 10 terms. This is a critical question, and let's try it out. Okay. Yeah, many of you got, yes. Blessy, Miss Blessy, you are writing T5 by T2. No, you cannot divide T5 by T2 to get the CR. Okay, yeah, T5 by T2 I have divided here to get, if you are talking about the last question, I think this one. Yes. Yeah, in this case, you have to divide so that you can eliminate. That is what I have done. Yes. But to get the common ratio, don't divide T5 by TR. That will not give you the common ratio. Okay. The sum of the first 20 terms of a GP is 244 times the sum of its first 10 terms. Okay. Okay. Let's take this. First 20 terms of a GP. Now S20, here we don't know anything about A and R. What is the common ratio and what is the first term, we don't know. And therefore, this is also I have taken up because of a quadratic equation. So S20 will be given by the sum of the first 20 terms is 244 times the sum of the first 10 terms. So I will take S20. S20 is equal to 244 into S10. 20 terms equal to 244 times the sum of the first 10 terms. Please follow. So this means S20 is equal to A into R to the power 20 minus 1 by R minus 1. And this is 244 into A to the power R to the power 10 minus 1 by R minus 1. R minus 1 cancels, A cancels. So I'm getting R to the power 20 minus 1 equal to 244 into R to the power 10 minus 1. This is what I'm getting. So if I substitute now, and let us take like this, let's take R to the power 10 equal to P. Okay. So if R to the power 10 is equal to P, then R to the power 20 becomes P square, because R to the power 20 means R to the power 10 to the power 2 raised to the power 2. So this is again, you see, this is an application of indices. Okay, indices which you must have already completed. So this is P square. So I can write P square minus 1 is equal to 244 into P minus 1, because R to the power 10 is P we have taken. So this boils down now to a quadratic equation, and we have to solve the quadratic equation. What have we got? We are getting P square minus 1. P square minus 1 is equal to 244P minus 244. So if I substitute, if I bring everything on the left hand side, I'm getting P square minus 244P plus 243 equal to 0. P square minus 244P plus 243 equal to 0. So let us solve and see what we get. Let us just solve and check. Please remember that P is nothing but R to the power 10, which we have taken in this example. So P is R to the power 10. Now, if you solve this, this becomes P square minus 243P minus P plus 243 equal to 0. We are breaking the middle term. And this is, middle term splitting, which we do in quadratic equation. From this part, we will take p common. So I'm getting p minus 243. From here, we take 1 common. So we are getting p minus 243, which is equal to 0. So the answers, the two roots of the quadratic equation becomes p minus 243 into p minus 1 equal to 0. So we have reached almost the final part of this solution. So we get two answers, either p equal to 243 or p equal to 1, either of them. Now we have to find out what is the common ratio. Now if I take p equal to 243, that means r to the power 10 is equal to 243. R to the power 10 is equal to 243. So because we had taken p as r to the power 10. And the other option, if you see, is if p equal to 1. Okay, if p equal to 1, what happens? Then r to the power 10 will be equal to 1, which means r is equal to 1. But that is not possible. If r is equal to 1, then it is not a progression. R equal to 1 means what? If the first term is, say, 5 and r is 1, then what will be the result? 5 into 1 is 5, 5 into 1 is 5, 5 into 1 is 5. It can be a sequence, but it's not a progression. So this is not the right answer. Please try to see why I'm not taking this as the right answer. So p equal to 243, r to the power 10 comes to 243. So this means that we have to find the 10th root. So if you multiply 3 and just use a calculator and see how many times it takes to reach 243. Let us try it out and check. Okay. So just doing step by step so that you follow. So 3 into 3 into 3, that is 27, into 3 gives you 81, into 3 gives you 243. So 243, we are getting 3 to the power 5 is 243. Okay. That means r to the power 10, 243 means we can write that this is basically 3 to the power 5 is 243. So we can just equate this in the following manner. R to the power 10 is equal to 243. That is what we got. But we can see 3 to the power 5 is also equal to 243. So we can equate r to the power 10 equal to 3 to the power 5. 3 to the power 5 actually means 3 to the power square root to the power 10. Okay, so therefore r becomes plus minus square root of 3. So this is the answer. This is the common ratio. So this is an application of quadratic equation as well. 6b number 20, the sum of the series 1 plus 2 plus 4 plus 8 to nth term is what? Okay, so let's try and solve it. Try and do it and check. The sum of the series 1 plus 2 plus 4 plus 8 up to nth term. Okay, so number 20. So 1 plus 2 plus 4 plus 8. So you can see this is a GP with a common ratio of 2. So CR equal to 2. So we have to find the sum till the nth term. The sum will be A is first term is 1, R is 2. So 2 to the power n, 2 to the power n minus 1 divided by common ratio 2 minus 1. So it is 2 to the power n minus 1, option number 1. This is actually 2 to the power n. Formula, if you use, it comes to straight away 2 to the power n minus 1. Exercise 6b number 23, the number of terms to be taken so that 1 plus 2 plus 4 plus 8 ultimately will become 8191. So this is just a formula based question and n will come to 13. So similar to the other questions, so I'm not doing it. Exercise 6c number 4. The sum of the first two terms of a GP is 5 by 3 and the sum to infinity of the series is 3. What is the common ratio? Okay, let us try and see. The sum of the first two terms of a GP is 5 by 3. So let me take the first two terms. One is A and the other is AR. So the first two terms is 5 by 3. So I take a plus a by r equal to 5 by 3. And the second information given in the problem is sum to infinity is 3. Sum to infinity, we know it is sum to infinity is a divided by 1 minus r. So this is equal to 3. So we get two equations, two unknowns. First is a plus a by r is 5 by 3 and a divided by 1 minus r is 3. So from here, let us solve for these two equations and you will get r is equal to 2/3. So this is the assumption. These are the two equations and two unknowns, a and r. We have two equations. Just solve for it. You will get r equal to 2 by 3. Number 13, exercise 6C. The sum of the four numbers in a GP is 60 and the AM of the first and the last is 18. What are the numbers? The sum of four numbers in GP is 60. Okay. The sum of four numbers is 60 and the AM of the first and the last is 18. So how to solve for this? Sum of the four numbers in a GP is given. Now you can easily find out that you will take the numbers as AR square and AR cube. So they are in GP with a common ratio of R. So first of all, it's given that sum of four numbers in GP is 60. So we can write S4 is equal to A R to the power 4 because it is 4 minus 1 by R minus 1. This is 60. This is the first equation we get. The second is the AM of the first and the last is 18. Arithmetic mean of the first and the last is 18. The first term we have taken is A and the second term is AR cube. So if I take the arithmetic mean of them, that means A plus AR cube by 2 is equal to 18 because 18 is the arithmetic mean. So we have got the second equation. Right, so we can, from here we can get a plus AR cube equal to 36. So we have got two equations. One is this one, the other is the one below. So this becomes a cubic equation, and provide if you are able to use the equation, you have done cubic equations. So you can see that for r equal to -1, this equation will become 0, which means r plus 1 is a factor, and therefore it will come up to r will become 2, or it can be half if from there you can get the series 4, 8, 16, 32. We'll take some additional problems. If the first term of a GP exceeds the second term by 2 and the sum to infinity is 50, what is the series? So I think options are given. These are questions on GP. So the first term of a GP exceeds the second term by 2 and the sum to infinity is 50. So you can see we are devoting maximum time to solving as many problems as possible. First term of a GP exceeds the second term. So the first term exceeds the second term by 2. So we can write the first term is A, second term is A minus 2. The sum to infinity is 50. What is the series? So the sum to infinity we know is S infinity equal to A divided by 1 minus R. And this is equal to 50. Sum to infinity is 50. So we have to find the series. Now we know that R is given. Okay, R is given already. So using the simple formula, okay. So we know that common ratio is R. Sorry, it's A by, sorry, we have taken A minus 2 and A. Now how to find the common ratio? Because we need to find R. R will be, this is second term, this is first term. So R is nothing but term 2 by term 1, that is A minus 2 by A. So this value we are going to put here. So we have S infinity equal to A divided by 1 minus R. A as it is I am keeping 1 minus R. Instead of R I am taking A minus 2 by A. If you solve, if this is equal to 50 as per the question, if you solve for A, you should be getting, if you work it out, you should be getting A equal to 10. So we get the first term is 10. Similarly, R comes to 4 by 5. Therefore, you can get the series 10, 8, 32 by 5, and so on. So this is also an interesting question. Okay. If the sum of n terms of an AP, we have done similar questions yesterday, the last class. So this is similar to that. Okay. This is an MTP question, of course. Okay. Let me take, this is a very interesting question. Additional problem 3. A certain ball when dropped to the ground rebounds to 4/5. This is a classic question from the Board of Studies. A wonderful question, and you try to see how the question, what the question asks you to do. So a certain ball when dropped to the ground rebounds to 4/5 of the height from which it falls. It is dropped from a height of 100 meters. Find the total distance it travels before finally coming to rest. Now, this is one of the best problems on GP, and just let us try to see how the ball is moving. So I'm just drawing, this is the surface. This is a height of 100, I think 100 meters. Okay, 100 meters. The ball is this. Now the ball is dropped. Just see the problem. It drops from 100 meters. It falls, but it rebounds to 4/5. It reaches here. Again it falls. Again it moves up to 4/5. Again it falls. It moves up to 4/5. It falls, moved up to 4/5. Just see the curve. Okay. So this is how it's moving. It's moving 100 meters. From 100 meters, it is dropped. It falls. Goes to 4/5 of the height. 4/5 of 100 is how much? 80. It falls again 80 meters. Again it goes 4/5 of 80. Again it falls. Again it goes 4/5 of 80. 4/5 square of 80, in fact. So in this way it goes on. We have to find the total distance it travels before coming to rest. Now, if you see the total distance it is traveling, now first of all it's falling from 100 meters. So I will write 100. Fine. Then it goes how much? It goes to 4/5 of 100. So it goes to 4/5 of 100. Again it comes down, the same. So 4/5 of 100 into 2 plus, it goes up to 4/5 of 100 is 80. 4/5 of 80. Okay, so 4/5 of 80 is how much? 4/5 into 80. So 16 4s are 64. So it goes up to 64 meters. Again it comes down. So in this way, if you see, it goes up and comes down, goes up and comes down, but the height is gradually reducing. Therefore, the total distance which it will travel, of course, it becomes an infinite GP series. What happens is the first 100 meters remains as it is, no problem. After that, what happens is plus 2 will be the common, because 2, it goes up, comes down, goes up, comes down. So 2 times, okay? So 2 will be common. Now, what happens later on is the options are given 600, 700, 900, and 200. Now, the options, it's already given. Let us try and find the solution. So that means it is traveling 4/5 into 100, 100 into 4/5, then 100 into 4/5 square, and in this way it is going. Here the common ratio, if you see, is 4/5. Okay, so therefore the total distance it travels, and it becomes an infinite series. First 100 is fine. Next it goes up to 80. So first height is 100, then 80, then 64, then 4/5 of 64, and in this way it moves. So the total distance it travels is 100 plus 2 into, it starts from here, 80. 80 plus 80 into 4/5 plus 80 into 4/5 square, and this way it moves. So finally what we are getting is, if you see, it becomes an infinite GP. In the infinite GP series, we know that the solution is given by summation is A divided by 1 minus R. If you look at the second part of the expression which is given, 100 plus 2 into 80 plus 80 into 4/5 plus 80 into 4/5 square plus 80 into 4/5 cube, in this way, since it is moving, now it becomes basically, here it becomes A is, in this case, we know A is 80. And here we can see R is 4/5. So I can put it like this, 80 divided by 1 minus 4/5. That means 80 divided by 1/5, that is 80 into 5, that is 400. But I also have to multiply it by 2 because it's already written 2 into the entire expression. So 2 into 400 is 800 plus the 100 which is left. 800 plus 100 is 900. So the total distance it travels, total distance is 900 meters. So this is one of the most intelligent questions on this chapter on GP, and I'm sure you can understand this. No, Chomo, this is not the right answer. Please check. 500 meters is not the right answer. Just check it. See, the ball is traveling like this. 100 meters, it falls. 100, that is separate. Now it goes to 80 and falls down. It goes to 64 and comes down. Okay, then it goes to 64 into 4/5 and comes down. So every time it is going up, bouncing, it is bouncing up and down. So it goes up, falls 2 times. Okay, so from here, if it bounces, say something like this, if the pen bounces from here, bounces, goes up, bounces, goes up. But every time the height is reducing. Okay, so therefore, the expression here is 100 will be separate, plus 2 into 80 is the starting point. Think of 80 as a starting point. Okay, so 80 is a starting point. It goes till 80 and comes back. Again, it goes to 64 and comes back. Right? So from here, definitely the common ratio is 4/5. And it's an infinite GP series because we are, of course, this is practically not possible. We are assuming just in physics, as we say, that everything remaining same, that you have to assume that there is no air, there is no resistance from the ground, absolutely frictionless, there is absolutely no coefficient of friction, which is, of course, in an ideal situation. So in an ideal situation, if it goes on till infinity, then it will travel 900 meters. That means total distance, it moves up and down. If you add it, it comes to 900 meters, but this is only an, you can say it's only an approximation, okay? Because the formula of infinite GP series is only an approximation, okay? Insert 4 M's between 3 and 18. We have done similar questions, okay? Let's take this one. The sum of terms of an infinite GP is 15 and the sum of the squares of the term is 45. What is the common ratio? Options are given: 3/2, -2/3, and 2/3. Sum of the terms of an infinite GP is 15. Okay, so let us try and check the question and try to, if possible, try to do along with me. The sum of terms of an infinite GP is 15. Okay, so the question is A divided by 1 minus R is 15, where A is the first term, R is the common ratio. And the sum of the squares of the term is 45. The sum of the squares of the term is 45. Again, that means in this case, the first term will become A square. Okay, and therefore, the sum of the squares. So therefore, first equation is A divided by 1 minus R is 15. And the second will become A square, squares of the terms. So therefore, the ratio, common ratio also becomes square. A square minus 1 minus A square divided by 1 minus R square becomes 45. So from here, if you solve it, we can get A by 1 minus R, we got 15. A square divided by 1 minus R square, if you see, is 45. So from here, you can solve. In fact, we can do it in this way. A square divided by 1 minus R square, we can write as A by 1 plus R into A by 1 minus R. This is 45. So from here, we will get definitely a particular ratio and a particular value which we can use, or we can also equate. In fact, this will give us A by 1 plus R is 3. A by 1 plus R is 3, and you know A by 1 minus R is 15. So from these two equations, you can solve for R, and it will be a quadratic equation. R will come to 2/3. Okay. Now let us take the sixth one. Find the numbers whose AM is 12.5 and GM is 10. So this is a combination of both arithmetic mean and geometric mean. Okay. Two numbers whose AM is 12.5 and GM is 10. Okay. So let us try and solve it, and then we will check it with the answers given. Two numbers, I am taking A and B. The AM is 12.5, so we can write A plus B by 2 is 12.5. That means A plus B equal to 25. First equation. Second point is the GM is 10. That is geometric mean is 10. Okay. In other words, we know that the geometric mean means the mean is given by GM is given by square root of A into B. So this is 10. So from here we can write AB equal to 100. So we know A plus B is 25 and AB is 100. So I think you can solve for it. The options are given. Now we can easily see that A plus B is 25, AB is 100. Okay, so let me take this as a quadratic equation. If A plus B is 25, then I can take A is equal to 25 minus B, and I will put this value here. 25 minus B I will put here. So it becomes 25 minus B into AB is 100. A is 25 minus B. So 25 minus B into B is 100. Now let us solve for this quadratic equation and see what it gives us. So these are little critical problems because this is, you can see, not a direct question. It is a combination of both AM and GM, and these questions could always be expected. So 25B minus B square equal to 100, which means B square minus 25B plus 100 is 0. So this means B minus 20 and B minus 5 equal to 0. So B is either 20 or 5. It's a quadratic equation. You can see we have broken the quadratic equation. So if B is 20, then A will be 5. And if A is 20, then B is 5. So the answer is 5 and 20. Option number 1. Okay, if the 8th term of an AP is 15, what is the sum of its 15 terms? Okay, options are given. Let us quickly solve it. As I said, I will take questions on AP also, and that is what I am doing apart from completing the entire GP, Infinite GP series, nth term, right? So we are trying to push on, and we will take few minutes so that we can solve for your sake, for your benefit. Officially, we are supposed to stop at 4, but we are pushing on. If the 8th term of an AP is 15, the sum of its 15 terms. So T8 equal to 15. It's an AP, please note. Sum of its 15 terms will be how much? 8th term is 15. So we can write A plus 8 minus 1 into D is 15. We have to find the sum of its 15 terms. So S15, this is equal to 15 by 2. 2A plus 8 minus 1. Sorry, 15 minus 1. I'm sorry. This is 15 minus 1 into D. This we have to find out. We don't know. So here we can see that this is coming to A plus 7D. A plus 7D equal to 15. A plus 7D is 15. Here we are getting 15 by 2. 2A plus 14D. 2A plus 14D means what? 2A plus 14D means 2 into A plus 7D. So 2 into A plus 7D will give you 2A plus 14D. So this entire part is basically 2 into this part. So 2 into 15. So I'm getting 15 by 2 into 2 into 15. 2 and 2 cancels. 15 into 15 is 225. So the answer comes to 225. 2 M's between 60 to 260. We have done problems like this. If an AP has 13 terms, whose sum is 143, the third term is 5. So the first term is what? So it has 13 terms, sum is 143, the third term is 5. Just let us carry it out and check. AP has 13 terms. Okay, so T13, S13. Sum is given. So 13 by 2, 2A plus 13 minus 1 into D. This is equal to 143. Okay, the third term is 5. So T3 is 5. That means A plus 4D is equal to 5. And here we are getting 2A plus 12D equal to 143. Of course, 13 by 2. So we have to find the first term. So A we don't know. A is to be found out. Now we know A plus 4D is 5. And in this expression, we are getting 13 by 2. 2A plus 12D is equal to 143. So you can take, these are two equations. So you can just solve A plus 4D equal to 5 and this one also. So from this two equations, you will be getting the value of A. Value will come to 2. Acha. last few questions, x plus 1, 3x, 4x plus 2 are in AP. Find the value of x. So let us just try and solve this also, since this is the last session on series and progressions. We are taking both GP and AP. X plus 1, 3x, 4x plus 2 are in AP. What is the value of x? So if they are in AP, very simple, we know three numbers are in AP. So A, B, C are in AP. That means B minus A should be equal to C minus B. So here 3x minus x plus 1 should be equal to 4x plus 2 minus 3x plus minus 3x. Let us see what do we get from here. 3x minus x is 2x plus, this becomes minus 1. Be careful about the sign. 2x minus 1 is equal to 4x minus 3x. That is x plus 2. So therefore it becomes x is equal to 3. X is 3. Fine, we have done it. The last one, this is a critical question, very critical. 11th question, if a by x, if a to the power 1 by x, okay, if a to the power 1 by x is equal to b to the power 1 by y is equal to c to the power 1 by z, and a, b, c are in GP, then x, y, z will be what? Now a, b, c are in GP. Please note carefully. Now let us equate it to k. Listen very carefully. This is, I've just stated that this is a very critical question, one of the toughest questions in this exercise, and also certain questions which can be expected in the exam, right? Now let us see a to the power 1 by x equal to b to the power 1 by y equal to c to the power 1 by z. If it is equal to k, then we can write a to the power 1 by x equal to k, definitely. So a is equal to k to the power x. This is based on indices. I hope you remembered your session on indices. So I hope you understand. If a to the power 1 by x equal to k, then a will be equal to k to the power x. Similarly, my dear friends, we can write b to the power 1 by y is k. So b will be equal to k to the power y. And therefore, c is directly equal to k to the power z. I think you have followed till this. Now the question, since A, B, C are in GP, so we have got the value of A, B, and C. They are in GP. And you know that if this is in GP, we will say B square has to be equal to AC. If A, B, C are in GP, it means what? It means B by A equal to C by B. So B square has to be equal to AC. If you just cross multiply, I hope you are following. So B square equal to AC. Now please note what we have done. We have got the value of A here, B here, and C here. Now we just equate. We create this expression B square equal to AC. So I'm just rubbing the upper portion and just trying to do it here. So we will just write B square equal to AC. Now B we have got k to the power y. So we can write k to the power y square is equal to AC. Now A we already got, A is k to the power x. So this is equal to k to the power x, and C is how much? C is k to the power z, k to the power z. Please follow carefully from here. This is also one of the toughest questions. This is, I have taken, once again, I'm trying to just let you know that every question I'm taking, even though it is more, it's beyond 4, we are still pushing. And that should be the spirit to go beyond and challenge yourself the ultimate extent. Okay, so k to the power y square is equal to k to the power x into k to the power z. This question I have taken specifically because it's a combination of AP, combination of GP, and combination of indices. One of the most beautiful question, at the same time one of the toughest question as well. Now if you can understand this, b square equal to AC, k to the power 2y. So you know that a to the power m to the power n equal to a to the power mn. This is indices, okay? This you know. So therefore I can write k to the power y square is nothing but k to the power 2y, and this is equal to k to the power x into k to the power z. Now you know if you multiply a to the power m into a raised to n, it becomes a to the power m plus n. So I can write k to the power x plus z. So since the base is same, we can write 2y equal to x plus z. which means y is equal to x plus z by 2. That means y is the arithmetic mean of x and z. Therefore, it follows that x, y, and z have to be in arithmetic progression. Okay, it's a lovely question, and I think you also will enjoy once you work it out yourself, and I'm sure you have followed it. Okay, this we have done. 6A number 1, similar questions we have taken up. The nth element of the sequence -1, 2, -4, 8, we have done similar questions. This is, you can see the common ratio is -2, and therefore you can, it's a GP, so you can get the answer. The sum to infinity of the series -5, 25, -125, 625 can be written as what? Just a one-line answer. You can see that here the common ratio is -5, right? And -5 means it is less than 1. Therefore, the formula can be applied, and as you know, S infinity equal to A divided by 1 minus R. Here A is how much? Here A is -5. 1 minus R means 1 minus -5. Be careful about the sign, as I told you. So it becomes -5 in the numerator, and in the denominator you have 1 minus -5, that is 1 plus 5. 1 plus 5 is 6. So the answer is -5 by 6. It's a GP, and therefore rest you can see answer is -5, and therefore we are getting A is of course -5, therefore the sum is -5 by 6. Okay, friends, so with that we come to the end of our session, and I hope that you have followed the discussion. We started with, of course, the important links for your studies, and then we went on to understand what is geometric sequence. I explained the difference between sequence and progression. Please remember, progression will always progress either upwards or downward, but if it is static, right, then it is not a progression. It's a sequence, no doubt, but not a progression. Then we went into the formula for understanding the nth term of a GP, and then the formula for the summation of the GP. The last formula we did, and what we just saw here, is the formula for the infinite GP series. Thereafter, we took number of examples, we solved it here, and examples included certain critical questions like combination of AP and GP, AP GP with indices, AP GP with quadratic equation, and also AP and GP combined in different permutations and combinations, right? We took number of questions from 6A, 6B, and 6C. Also number of additional questions. So see you next day. This is the last session on the sequence, series, and progressions. Next session we are starting with sets. Then we will move into the important chapter of equality of, I think we have functions and equalities, right? So functions and relations, of course, and we will also see some important formula in that particular chapter. So see you next time, and please go through these questions which we solved, and please try to download the mock test paper and start revising the questions, trying to solve the questions under exam conditions, right? See you, and thank you.